Hello and welcome to your Mind IDE for a continuation of the probability section. So today we're going to be looking at something which is called Bayes' rule. So basically the way that it works is so when you're trying to compute probability, this notation, what this means is the probability of A given B. So prob of A given, probability of A given B. So it's the probability of A happening given that B has happened or will happen or something like that. And basically how you set up this equation is like this. B given A, P A, and P B. So P of A given B is equal to P of B given A multiplied by the probability of A divided by the probability of B. And that might be confusing, so we're going to go through an example. So Bayes example. So we're going to have an example question. We're going to use this, it's a pretty common one, became pretty popular around a certain time period when there was a particular disease going around that they were doing a lot of testing for, which you might remember from, when was that, 2020, somewhere in there, 21, somewhere in that time period. So basically the way we're going to set this up is you're going to have a test which is 95% accurate. And this is for a disease, we'll say. And we'll say that it's known that 2% of the population has the disease. Okay, so just to set up the scenario here, there's a home test kit that you have. The home test kit is 95% accurate, and we know that 2% of the population, of the entire population, has a disease. And what we want to know is, how likely is it? So how likely is it that a person who tests positive has the disease? So you take this test kit home, you test yourself, you're positive, you know that 2% of the population has the disease. How likely is it that you actually have the disease? So that's what we're going to try to figure out. So the way you can set this up, we're going to have TP, which is test positive. TN, which is test negative. AP, so this is actual positive, and AN is actual negative. So again, what does this mean? So TP, test positive, is the test is positive. Test negative, the test is negative. AP, actual positive, is the person is actually positive for the disease. AN, actual negative, the person's actually negative for the disease. So how do we do this? We go P of TP, AP. So what this is you test positive given you're actually positive. So we know that is 90, so it's 95%, which equals 0.95. Probability that you test positive when you're actually negative is 0.05%. Or not, 0.05, which is 5%. Probability that you test negative when you're actually positive is 0.05 again. And probability that you test negative when you're actually negative, oh, why do I keep doing that, is 0.95. So can we make sense of this? So you're always going to have to add up to 100, right? 100% of the cases. So the first one is you test positive when you're actually positive. It's a 95% chance. The test is 95% accurate. So it's a 95% chance. Test positive when you're actually negative is a 5% chance. Test negative when you're actually positive, 5% chance. Test negative when you're actually negative, 95% chance. So that's directly because it's a 95% accurate chance that the test is correct. It has a 95% accuracy rating. Okay, so from that we get those numbers, but we also know from this 2% we have another couple of probabilities here. Probability of actual positive is equal to 0.02, which is 2% of the population. Probability of actually negative is 98, which is 98% of the population. Okay, so all of these in this column here, all of these here are on the basis that we know if the person is actually positive or actually negative, and then we're doing the test. But what about the other way around? That's what we're looking at. So we want to find out the probability that you're actually positive given that you test positive. So the big difference between this and say this one, so in this one over here, we know the result already, and then we're doing the test. This one we don't know. We just ran the test blind, and we want to know what is the probability that the person's actually positive. So we can set this up just how we had this set up, this Bayes rule. So we know this, we know this, and we know this. Those are all in here. So we have P of TP given AP. I'm going to run out of room here. Multiplied by P of AP over P of TP, which if we look, this is set up so AP TP. So this is like AP TP. So then this would be TP. This is AP. this is AP, this is TP, which is how we've set this up here. And then all we have to do is apply this. However, what we don't know, the one thing that we don't know, we have this and we have this, but we don't have this one. And as it turns out, we can actually, we have an equation for that as well. So our probability that we test positive is equal to P of TP given AP plus P of, or wait a second, TP AP, no, that's not plus, multiplied by the probability of AP plus P of TP given AN, probability of AN. So the probability that you test positive is equal to the probability that you test positive and you're actually positive multiplied by the probability of actually positive plus the probability that you test positive you're actually negative multiplied by the probability that you're actually negative. And the reason that is, I hope you know some other probability stuff. That's kind of what this video is assuming. Otherwise it'd be a much longer video. We'd have to go through a bunch of other probabilities. It's basically if a probability is independent or dependent. So now we can substitute, or we'll just remove that, and we'll change this to what that's equal. Plus P of test positive, actually negative, probability of actual negative. Okay, and now we can sub in numbers. So we have all of these different probabilities. So the first one, test positive, actually positive, is again this guy here, which is 0.95. And we multiply that by actually positive, which is 0.02. We divide that by test positive, actually positive, which is 0.95 again, times actually positive, 0.02, plus test positive, actually negative, which is this one here, which is 0.05 or 5%, and multiply that by probability of actual negative, which is 98% or 0.98. And when you calculate all this out, you end up with 0.279 or 27.9%. So that's the answer. So basically, if your test is 95% accurate and you test positive and 2% of the population is positive, the probability that you're actually positive is 27.9%, which might seem odd, but that is the way that the probabilities work out. And let me know if this stuff is confusing. If it is, and you'd like to see a video where we dive a little bit deeper into how these dependent and independent probabilities work out, let me know. We can do a more fundamental probabilities video. But otherwise, thank you so much for watching today. Hopefully this was helpful for you if you were trying to figure out Bayes' rule, or if you just wanted to see an example of Bayes' rule being solved. If it was helpful or if you enjoyed it, please give the video a like, and also consider subscribing to the channel. The channel is still very new, very low subscribers, so every little bit helps out. And I really appreciate anyone and everyone who does decide to support me on this. Really does encourage me to keep going and make more videos. And also let me know down in the comments what you'd like to see more of, if you like more of this probability, or if you'd like some other topic like pure mathematics, calculus, coding, physics, engineering, anything like that. Or if you have any requests for specific problems, let me know as well. Thank you so much for watching today. Till next time, take care.